The nation's 104 nuclear energy plants are operating more reliably than ever. That's because skilled professionals at every plant maintain the equipment in top condition. Engineers at 2 nuclear stations found new ways to detect and prevent a condition called stress corrosion cracking that can potentially affect metal components.
I used to work in a pipeline industry. You'd have 12-inch, 24-inch pipe that ran maybe for 20 miles. And literally, you would have an area the size of a postage stamp with a problem in it. It's very difficult to find.
Until now, the best way to ensure safety has been for plant operators to periodically replace these parts. But engineers at the Salem nuclear plant in New Jersey and the Fort Calhoun nuclear energy station in Nebraska thought the time and money spent on replacing pipes could be reduced significantly. They were right, and the nuclear industry honored them with awards for their innovation. Both started with proven technology and applied it in a new way.
In the case of Salem, they instituted that mechanical stress improvement program in a more comprehensive manner than anyone else did. And in the case of Fort Calhoun, they basically came up with a unique prediction method that no one else has developed thus far.
Mechanical stress improvement is a process used in boiling water reactors to reduce stress on small pipes.
Basically, hydraulic equipment is placed on the outside of the pipe, and by squeezing it causes the inside to go into a highly compressive state.
But Salem is a pressurized water reactor, not a boiling water reactor, and the engineers there were working on pipes twice the size.
What is unique about this application here, it is the first time that it's ever been used in a pressurized water reactor. The pipe diameters are much, much larger, so the challenges were developing the hydraulics, the challenges were developing the infrastructure to deliver the system, and to create the accessibility into an area around the reactor vessel nozzles.
At Fort Calhoun, engineers wanted to figure out how to better predict where very small cracks in metal components are likely to occur. It turned out that a common inspection device was already providing information that predicts where problems might show up, but it took the Fort Calhoun team to figure out that the information was meaningful.
Sometimes, whether you want it or not, you'll get more signals than you need. And what we found was the noise or the extra signals from this testing was actually telling us more about the component than we knew it was in the first place.
For 10 years, Fort Calhoun engineers tested and compared metal plant components that had experienced cracking with plant components that didn't, and worked with an independent lab in order to be absolutely sure their predictability test was accurate.
So what we found was a perfect predictor of when problems would occur in a component. And that's the essence of it. It was basically one man's trash is another man's treasure. And that's what it became. It became a treasure for us, a treasure trove of information.
The bottom line? Salem and Fort Calhoun saved millions of dollars by applying proven technologies in new ways. Better yet, their findings can easily be adopted by other nuclear plants.
And this is not unique to Fort Calhoun Station, Omaha Public Power District. It's applicable to all plants, not just in the US, but in the world. And it's the first time that this methodology has been able to predict when problems will occur.
I suspect, based upon our experience and the successful use at Salem 1, that there will be many other utilities who will give consideration to that process as opposed to some of the more new, untried, unproven technologies that are still in developmental stages.